Hi, welcome back to the Math Studio. I'm going to try to make it through this next segment without making any mistakes. I know that's a really tall order, but we're going to try our best. So we're going to take a look at some applications. Let me make this a little bigger. So applications of vectors. The main two that we're going to be noticing in calculus are force and movement. So force, you can imagine pushing against an object. That would be a vector, the force that you use to push against the object. And then movement, you have something moving. And in fact, the very first example that we have here is going to be a movement example. So I need to be able to do my iPad thing again. So let's go ahead and take a look at this. A plane is flying at a heading of 32 degrees west of north. So whenever you see this, 32 degrees west of north looks like this. Your north here is east, south, and west. So the y-axis is going to be north, the x-axis is going to be east. So hopefully you know your compass headings. If you don't, I don't know how to help you. Okay, so moving on, we have this angle. This is 32 degrees. So that's the direction of the plane, and it tells us that the magnitude or the airspeed is 325 miles per hour. So it would be kind of nice to know the actual component version of that vector. Fortunately for us, we've just learned polar coordinates. And so we're going to use the polar coordinates to come up with this. Specifically, we need this angle because our polar coordinates use that angle, not that other one. And so this is 58 degrees. That's a horrible looking 8. But the x coordinate here is 325 times the cosine of 58 degrees. This is lagging a bit. And let's get rid of this. And then 325. Oof, it's terrible. 325 times the sine of 58 degrees. I'm just using my polar coordinate to rectangular coordinate conversion formulas. R times cosine theta and R times sine of theta. So that's this vector right here. We'll call that vector V for plane. No, it doesn't make any sense. Okay, the next thing is the wind is blowing due east at 25 miles per hour. So I'm going to draw that in a different color. How about purple? So we'll do that. 25 miles per hour. And that's a lot easier. We'll call that W for wind. That's 25 in the x direction and 0 in the y direction. They want to know the actual direction and speed of this plane. Well, what's happening is the plane is flying under the force of its engines this direction and that speed. The wind is blowing the plane this direction with that speed. And so the sum will be the actual direction and speed. Sorry, I forgot to press the shift key there. Just kidding. Keyboard joke. Okay. So V plus W will be the sum of those two vectors. So we'll do 325 cosine of 58 degrees plus 25, and then 325 times sine. And I haven't left myself enough room, so give me a minute here. Let's move that over. Sine 58 degrees. Okay, that's supposed to be an angle bracket on the end there. Okay, I have to whip out my calculator. Where is my calculator? Oh no, I don't see it. Pause. I found it. It's in the other room. I must have been doing something. I don't know what. Okay, so we need 325 times, oh, make sure that I'm in degrees. Oh, there I am in degrees. Okay, so 325 times cosine. I just got done saying that we always use radians. Well, we use radians in calculus except where we use degrees. But actually, calculus is always done in radians. That is, if you do derivatives, integrals, always radians. So this is neither. So anyway, so let's see, we're going to plus 25. And so this gives me 197.22. And then 325 times sine of 58 degrees. And that's 275.62. So there's my vector that actually describes the motion or the actual direction the plane is going. It's the sum of these two vectors that are in this here. So now I need to know what's the actual speed. The speed will be the magnitude of v plus w, which will be the square root of 197.22 squared plus 275.62 squared. So give me a sec. Let's see, square root of 197.22 squared plus that thing squared. And I've got 338.9 miles per hour. So that's the length of this vector that we just computed. Now the direction, what I'm going to do is I'm going to compute this direction like this. Let's see, first of all, I need to draw this on here in a different color. How about light green? Let's see if that works. So here is the vector. So notice I've got the speed or the wind speed moving the whole thing over. So I need this angle. This angle is the angle I'm going to get. Fortunately, I'm in the first quadrant, so the direction, I'm just going to use the tangent of that angle is y over x. So let's see, we have, so I'm going to do the arctan of 275.62 divided by 197.22. Is that it? Okay, and I'm getting theta equals 54.4 degrees. So my direction is 54.4 degrees north of east. Or I could figure out the direction in terms of north and east. I could do the other angle, but this is all I really care about. If you do this on a test, then I'll be happy and I'll give you your A++ that you deserve. All right, let's move on to another example. So let's say that a plane flies 30 degrees north of east at 400 miles per hour, and the wind is moving 400 or 50 miles per hour from the south. Let's do this one a little quicker. Let's see, small. There we are. So we have this. Whoops, that's not right. Let me draw my axes. We have this, 30 degrees. And so here's the plane, 400 miles per hour. So this plane is going to be 400 times the cosine of 30 degrees, which is 200 radical 3. Cosine of 30 is radical 3 over 2. So if you did this on your calculator, you'd get 200 times 1.732, whatever that is. And then the sine of 30 degrees is 1/2. So 400 times 1/2 is 200. Now let's put the wind speed in there. The wind is out of the south. So that means it's pointing this direction and it's going 40 miles per hour. So the wind is going to be 0 and 40. So now we'll do, we'll call that W, we'll call this one V, and then we'll put them together. V plus W is 200 radical 3, and then 200 plus 40 is 240. So that first component is just 200 radical 3 plus 0, and then 200 plus 40. So what do we got here? We're pretty much done other than getting the magnitude. The magnitude of this thing will be So let's see, the magnitude is the square root of 200 radical 3 squared plus 240 squared. And this I cannot do in my head, so if you'll bear with me, times squared plus 240 squared, and I got 177,000. We're going to do this, the square root of that. I got 421.4 miles per hour. So the actual speed of this plane is 421.4. The actual direction is whatever direction this is. Once again, this is first quadrant, so the tangent will work out nicely. Tangent, whoops, theta. Let me just get rid of that. So the tangent of the angle will be 240 over 200 radical 3, which I don't really care what that is. I'm just going to do the inverse tangent of 240 divided by 200 radical 3. And I put that 200 radical 3 in parentheses because I'm scared of the calculator not knowing what I intend. And I think I got that. So I'm getting theta is 34.7 degrees. So there you have it, some motion problems. In the final video that we have for this section on vectors, we're going to take a look at some forces.